So me and Eric come to a property today. The customer said that their dishwasher isn't working. It's actually an integrated appliance. So as you can see here, the first thing we checked, okay, obviously by pressing the on off button, it sounds silly, but sometimes it can be that. We had no power. So then we checked just to see whether a local fuse had gone. We checked continuity in the fuse was fine. We checked the overcurrent protection device, again that was fine. Everything else is working, all the other sockets, we've done some testing there. We're gonna plug in, okay, and we're gonna test for voltage. And as you can see on the tester, between line and earth, our protective earth, we actually have 240 volts. So at this point, you almost start looking for something else because you think, oh, there's power here, okay. But then if we check between neutral and earth, we actually have 68 volts. And if we check between line and neutral, we're only showing 177 volts. Looking at this, we have 240 there between line and earth. So we know, generally, we can sort of say from that, our line conductor and our CPC is actually doing what it should, and we're getting a good reading there. However, we're getting a bad reading between neutral and earth, and a bad reading between line and neutral. So the common fault there, if you like, is with the neutral. As you can see, when we introduce the neutral into these voltages, when we're testing between them, that's when it changes and we get a reading we don't want to see. So we can't at this stage really 100% say we have a problem with the neutral. In this video show testing how we can prove that and see if there is an issue with our neutral conductor. So now that we've looked at the voltage and we can see there's some sort of an issue there, what sort of test do we go and do next? Do we do an insulation resistance test? Well, not actually tripping any of the overcurrent protection devices or blowing the localized fuse. So assume that the condition of the cable in itself is okay. What we're actually looking for, if we're not getting a supply, we're probably looking for a potential break in a cable. Undertake our continuity of CPC tests, okay, and we're going to check that we have continuous conductors from one point to the other. We could do this with a long lead test, okay, and we could probe onto the line one end, the line in the socket outlet, see if there's continuity. Again, we'd call that a throughput test. We can do the same with the CPC and the neutral. However, what we're going to do is we're going to do this without a long lead test, okay, and we're just going to sort of use our R1 plus R2 method to distinguish whether we have a break. Now, because this is a radial, okay, this is actually fed from a module unit there, okay, a grid switch, okay, and you can see that I've actually linked together line and neutral within the back of the switch for the dishwasher, okay. So what we're going to do now is we're going to change our meter to continuity. We're going to make sure the probes are in the back the correct. By that I mean, because we're testing line and neutral, we need line and neutral in L1 and L2, okay, so it indicates line and neutral on the plug top for our test equipment. So when I plug in now, I should expect to see a reading. Now, I don't, you see, so we have a value greater than 999. So that is telling us that we have no continuity between either with our line conductor, okay, or our neutral conductor. We won't know which one it is until we now do the test between two more conductors. So if we change this to our neutral and our CPC linked together there, and we don't have a reading, then we can assume our neutral is the issue. If we do have a reading, then we can assume that our line is the issue. So we have to prove two of the three combinations to confirm polarity, if you like, as well. So now we've linked our neutral and our CPC. Okay, again, what we're going to do now is we're actually going to change in the back of our tester, we're going to change the line conductor for our CPC. Remember, on our plug-in lead here, okay, the color indicates the conductor in the plug top. So now we're doing neutral and CPC. Okay, so all I'm going to do is I'm going to plug into here, and again you can see I have no continuity. So I've had no continuity between line and neutral, and none between neutral and CPC. With the information we gathered earlier with the voltage issues, we knew when we introduced the neutral it was causing an issue. Now we don't seem to have continuity with the neutral at all when it's combined with either the CPC or the line. I don't need to at this point, but just to prove this, what we'll do is we'll link line and CPC together, and then we'll perform the test again and see if we get continuity then. So now we've linked the grid switch. What we're going to do, we're going to need to put our line and CPC in the back to indicate on the plug top. And now, if we switch the socket on, as you can see, we actually have continuity now. So we have continuity between line and CPC. We don't have continuity between line and neutral or neutral and CPC. Therefore, this is showing us, okay, that in fact, we do have a break in the neutral conductor. So again, just an easy way of fault finding, okay, using dead testing. There was no power to the appliance, so what do we check first? Fuses, etc. For loss of supply. All the fuses and overcurrent protection devices were fine. Therefore, our first thought then, is there a break in the cable? Because there's a loss of supply somewhere, so something is stopping power from getting to that socket outlet. In this case, we found out it was the neutral conductor, but regardless of which conductor it is, by following that process, okay, continuity of CPC, you have to do 2 combinations. You link the conductors out, test for continuity. If there is continuity, you can almost disregard them conductors. If there isn't, then you must perform another test really to just confirm. The problem we have now, okay, so we understand that we have an issue with the neutral. The problem is the cable actually goes up by the look of it here, okay, but we're down to a dishwasher. So trying to find a reference point where the break is going to be very, very hard. So we need to sort of think about how we can get a new feed to that socket outlet so they can have their dishwasher working. We hope this video, Eric.
It's been some help.
Where's the thumb? There we go, good lad.